look at these four integrals. They are not really difficult, and they are similar. So I will put them together to do just for the basic training of techniques of integration. So here I do two of them, and the other two, well, I leave it for yourself. You can practice. It's a very good exercise for the basic training, the basic integrals. Now let me do the first one. The first one is the integral sine inverse e to the x over e to the x dx. Now first I will rewrite this one as a sine inverse e to the x and e to negative x dx, right? And this one is equal to sine inverse e to the x and d e to the negative x, and I leave negative outside, right? So that is equal. Now here I can use by parts. This will be equal to negative. This is u, this is my dv. So equal to uv is this, x, minus v du. You have a minus here, so become plus. Integral v du. V is this. Du is the derivative of x sine e to the x with respect to x. So that will be equal to 1 over e to the ex being square, right? Then the derivative of e to the x, that is e to the x, and dx. Yeah, that's good. And then this one is equal to negative e to the negative x sine inverse e to the x, and plus integral this put it into the denominator. This is 1 minus e to the 2x, and here I'm going to write the derivative of e to the x, right? Dex is equal to ex to ex dx. So they're equal. Okay, so this one is equal to negative. I can plot this into denominator. So it's inverse of e to the x over e to the x. And this one, by parts again. No, not by parts. Rather, let u be e to the x. So this integral using by substitution, plus integral du, right? This is u. This is 1 minus u squared. Okay. Then I use substitution again and let the u be sine theta. So this integral becomes negative arc sine e to the x over e to the x plus integral u is sine x, so this is cosine theta d theta. This is sine theta, and 1 minus sine square is cosine square, and then becomes a cosine. So this becomes negative sine inverse e to the x over e to the x plus integral cosine cancel out. 1 over sine is cosecant, right? Cosecant theta d theta. Now, if you don't remember this formula, cosecant derivative integral, I can use this, right? Cosecant is equal to what? Is equal to cosecant minus cotangent, cosecant multiplied by cosecant minus cotangent d theta. And this one is equal to, this is a cosecant square minus cosecant cotangent theta d theta over cosecant minus cotangent. And this denominator is this. The numerator, this is the derivative of cosecant minus cotangent theta. This derivative is this, right, after negative. This derivative is negative this. But overall, this one becomes a log cosecant theta minus cotangent theta. See? So my result is equal to negative arc sine inverse e to the x over e to the x plus natural log cosecant theta minus cotangent theta plus C, right? Now, to convert back, I need a triangle, right? This is a triangle, this is a theta. My assumption sine theta is u, so this is u, this is 1, this is 1 minus u square. And then this one is equal to negative e to the x arc sine e to the x plus natural log cosecant. Cosecant is 1 over cosine, 1 over sine. Sine is u over 1, therefore this one is called 1 over u for cosecant. Cotangent is this over this, right? So minus 1 minus u square over u. Then we replace u back, u is the e to the x. So finally I get this. E to the x plus natural log 1 over, this is a u, right? The u is e to the x, and this is 1 minus square root 1 minus e to the 2x plus c. And then this is equal to log the numerator minus log a new denominator. So this one is equal to e to the sine inverse e to the x minus, this is x, right? This is x, and the plus natural log 1 minus square root 1 minus e to the 2x. That is my result for this integral. Okay, that's the first. Now the second one is this: integral arctangent e to the x dx over e to the x. Well, same as I said in the beginning, that these integrals are quite similar. Arctangent e to the x, e to the negative x dx. Then I associate these two as the derivative of e to the negative x, right? These two is this. And there's a negative outside. I'll leave negative outside. So this is arctangent e to the x. Now then I can use by parts. By parts says that uv, u times v, right? This one is this. Minus v du, minus, you have a minus here, so become plus. V du. This one is this. Cosine, arctangent derivative is this is 1 plus e to the 2x, right? Times e to the x dx, the chain rule. Yeah. Now then, this is negative e to the negative x tangent, arctangent e to the x. And this one cancels out, becomes a 1, right? It becomes plus 1 plus e to the 2x dx. Well, so far so good. Now this one is equal to negative e to the negative x arctangent e to the x plus, I can write this one 1 plus e to the 2x into 1, there's a 1 here, right? Plus e to the 2x minus e to the 2x. Sorry, the plus dx. Then this one over this one is 1 plus dx minus this one over that one. This one over that one I can write 1 plus e to the 2x. Right? This one over that one. This one I can write as 1 plus e to the 2x. This derivative is e to the 2x times 2. I don't have 2 here, so I multiply 1/2 here. So the result is done. The result will come up equal to e to x plus x. This one equal to natural log, right? 1 plus e to the 2x. Yeah. So this is my result, right? You can write this denominator. This could be arctangent EX over e to the x. Okay. Now, I did I did this one, and I leave this one and that one for yourself. You can try at home by yourself. Use similar techniques as I've done in these two. And this is a very good exercise for those who take the basic calculus course. It's a good example, good exercise to do the training for the techniques. Now I leave the answer here. You can verify, or if I have some errors, the best verification is that you take a derivative of this antiderivative. You take a derivative of this one with respect to x and go back here, then it's correct, right? So, but anyhow, I leave those results as a to your reference. Okay, thank you. Thank you for your watching.